Good morning, everybody. So today we're going to be starting our very last unit, which is talking about things within our galaxy and universe and solar system and everything. So we start by talking about the components of the universe. So we're going to be looking at some notes with that, and we are borrowing from someone again with their the way that they had theirs styled, and so it'll look familiar in terms of what we did last time. And so you are going to have in your Google Classroom the components of the universe notes for the student slides. And so they'll look like this, where you have pages that are going to have pictures and definitions that you'll match up as we go. And so that part, and then you'll have the videos that we're also going to be watching in class. So I won't play those in the video that I make separately for the notes part. And actually I may just go ahead and make it all in one video today. And then there's one for the life cycle and one for a place where you can start filling in blanks, which is this one I think is part of the close activity. So I think probably these two should have been switched, but I didn't do it before I assigned it, unfortunately, and so now it's too late, so it's okay. But this one you'll fill in blanks with the correct words, and then you've got pictures that will also fill in on those. So that's kind of how this activity works. So I'm going to go ahead and do it all in one video because this one shouldn't take too long, and so I think I'll have time. So basically, as we start talking about the components of the universe, this first student objective is a fairly large one. In terms of what you have to know, we'll spend a lot of time with this first objective. We'll start it this week, but then we'll come back to it next week. And with all the testing we've got going on next week, we may come back. We may still not be finished until the following week. The other three objectives that deal with space all together take about a week. So it's kind of weird the way this is set up. But basically, you're describing the components of the universe, so what makes up the universe, including stars, nebula, and galaxies. But within the including stars, we go more in depth and talk about what's called the HR diagram. And so this one takes a little bit longer. So there's an entire another day of notes that just is dealing with the stars. So that's kind of where we go with this one. So for our components of the universe notes, first, the universe in general includes space and all of the energy and matter in it. I'm going to go kind of quickly through the video so that I have enough time, but you can feel free to pause and rewind and so forth as you're filling in if you use this to fill in your notes. And so there is a video that you can watch, but like I said, you've got these videos all on one page in your student notes version. I just forgot where it is. There it is. So most of these videos come from there. And so that's where you're going to be getting. So on your page, you're going to match those and fill those in. So let's move on. And then a galaxy is a large collection of stars, gas, and dust that is held together by gravity. And so basically think about universe. Uni means one or all. So basically it's everything. All the energy, all the matter, all empty space, everything that we know of is the universe. Technically, if we know about it, it fits in our universe. If we don't know about it, it's not in the universe. And so until we know that there's something else out there, we consider it to be in part of our universe. If we find out that there's something else that we didn't consider part of our universe that might be like a separate dimension or something, then maybe we start talking about something else. But as of right now, everything we know about fits into our universe. Galaxies, there are different types of galaxies. We'll look at that in just a second. But basically, it's held together by gravity. They do move, they do rotate. And so all of the stars, all of the dust, all of the gas that's there is moving, and it is what we would consider like a living body because it's all changing. And stars do have a life cycle that they go through. Even though they're not alive, we consider it like a living body because of all the growth and change. So these are the different types of galaxies that we deal with. The most common types that you'll see are spiral, irregular, and elliptical. We don't usually talk about peculiar because most peculiars fit into irregular. And lenticular, most of the time, if it's lenticular, we just classify it as part of an elliptical. So these first three and elliptical are the ones that we talk about the most often. And so spiral has like pinwheel arms, and it looks like kind of what I would say like a hurricane. You've got the eye of the storm and then those arms that come off of it. Irregular just looks like a blob. Barred spiral is similar to a spiral in that it still has those arms that come off of it, but it typically just has one arm that comes off of one single like bar off the middle with that dent center. Irregular, like I said, is just a blob. Elliptical tends to be more not necessarily spherical shaped, but it's got more of that circular or ellipse, like egg almost type shape to it. And again, you've got these videos you can watch. Nebula. Nebula are large clouds, or nebulae, if you're talking plural, are large clouds of dust and gas where the stars are born. So within these large clouds of dust and gas, gravity over thousands of years starts pulling that dust and gas together. As it gets more and more, it has more gravity. It continues to pull it in. Eventually, it gets so massive and the gravity is so strong, it starts to fuse those atoms together. Once nuclear fusion starts, then you start to have the stars shining and producing the energy. And so that's when the star is actually born. Solar system. So we're getting smaller as we go. So we start with the universe, which is the largest. Then we have a galaxy, which is next. Within the galaxies, you have nebulas. Now we're talking about our solar system. So the whole solar system contains small and large bodies that orbit, in our case, the sun, but it could be any star. Every star could have its own solar system. And then again, there's another video for you. A star is a large celestial body that is composed of gas and emits light. So it's producing through fusion its own light and heat. So the gravitational force is pulling all of that gas in to the point where the nuclear fusion is happening, and that's how it's producing that light and heat. This shows the life cycle of a star, which we will talk a lot about as we look at the next day too. So basically it starts as a nebula, and then depending on its mass when it starts fusion, it has two different basic paths that it can go through. If it's an average sized star with average to low mass, at the end of its life cycle, it starts to expand and it will become a red giant. But then all of the outer levels just kind of blow away and escape as the gravity lessens. And the core becomes what we call a white dwarf. Those outer gases just become what we call a planetary nebula. And you're just left with a white dwarf, which can burn for millions of years or more. If it's a very massive star, it's much brighter and hotter, but it lives for a much much shorter time, because it burns through its energy faster. It becomes a red supergiant, so even larger. It will go through a supernova instead, meaning the entire core collapses upon itself and then explodes. And then again, depending on its mass, will have one of two endings. The most massive stars will end up forming a black hole. If they are slightly less massive, they end up forming a neutron star, which can also be called a pulsar because they spin very, very fast and emit pulses of energy. So those are basically your paths that they can take based on their initial mass. And you have another video. Black holes are a place in space where gravity pulls so much in that no matter, not even light can escape. So that's why they're called a black hole. We can't really see a black hole. We can just see where a black hole exists because of the fact that there's no light around it. And stars, if they're passing behind a black hole, seem to disappear and then reappear. And so that's how we can tell that there's a black hole there, is because there's an absence of light and things disappear for a moment and then reappear, and we can tell that they passed behind it at that point. Asteroids are the small rocky bodies that orbit the sun. There's an asteroid belt between Jupiter and Mars. Meteors are small rocky bodies that enter the Earth's atmosphere. They tend to burn up in the Earth's atmosphere and never cause problems, but sometimes they can get all the way to the Earth, and then they're called a meteoroid. Comets are celestial objects consisting of ice and dust, sometimes called dirty snowballs. When they near the sun, they form a tail of gas and dust particles, and that tail is blown away from the comet by what's called the solar wind, and it glows and we can see the comet's tail. Okay, so these two, you've got the one that you're going to fill in before that and then answer the question on this. So you will turn in this, and like I said, you can always pause, rewind, so forth on the video, and then you will answer this question to put them in order from largest to smallest, and then turn this in. If you want to copy your slides and put them in your digital journal so you have all that information in one place, you may do that. And other than that, that is all of the notes for today. And we will have some more that will give us a little bit more information on stars specifically and on what's called the HR diagram. So we'll look at that later. Okay, so hope this helps. If you get lost, you can rewind, you can ask questions, and I will talk to you later. Have a great day.